Download this code from codegive.com, link in the description below. Locking binary files in Gitolite, a comprehensive tutorial. Gitolite, being a lightweight access control layer built on top of Git, doesn't inherently have a built-in file locking mechanism specifically designed for binary files. However, we can leverage Gitolite's permissions system, combined with Git hooks and other supporting scripts, to create a pseudo-locking mechanism that effectively prevents concurrent modifications and ensures data integrity for your binary files. Why lock binary files? Unlike text-based files, binary files are typically not easily mergeable. Concurrent modifications by different users can lead to data corruption and loss. Common examples of binary files that benefit from locking include *images, .png, .jpg, .tiff, *audio/video files, .mp3, .mp4, .avi, *databases, .sclite, .mdb, *design files, .psd, .ai, .cad, *executables, .exe, .dll, .so. The approach: permission-based locking with hooks. This tutorial will outline a method based on the following principles. 1. Controlled write access. Use Gitolite's configuration to restrict write access to specific binary files or file types. Only authorized users will be allowed to lock and modify these files. 2. Pre-receive hook. Implement a pre-receive hook that checks for lock files associated with the binary files being modified. The hook will reject the push if the file is already locked by another user. 3. Lock files. Create lock files alongside the binary files. These files will contain the username of the user who has locked the file and potentially a timestamp. 4. Lock/unlock scripts. Provide scripts to easily lock and unlock binary files, creating and deleting the lock files respectively. These scripts interact with Git to add, commit, and push the changes. 5. Error handling and messages. Ensure that informative error messages are displayed to the user when a lock is violated or when a lock file already exists. Prerequisites. A functioning Gitolite server installation. This tutorial assumes you have basic familiarity with Gitolite administration, users, repos, rules, etc. Basic knowledge of shell scripting, bash, sh. Access to the Gitolite server's file system, usually via SSH. Git client installed on user machines. Step 1, Gitolite configuration, gitolite.conf. First, we need to configure Gitolite to restrict direct write access to the binary files. We'll create a rule that allows only specific users/groups to modify these files. Explanation repo my_project defines the repository where the locking mechanism will be applied. Replace my_project with your actual repository name. *r equals at all, grants read access to everyone. This is a common setup. *rw/head/master bin/star.png equals @admins, crucial part. This line grants read and write access only to members of the @admins group, which you need to define in Gitolite, for files with the .png extension in the bin/directory within the master branch. You can customize the branch name and file path. Change .png to match your desired binary file extensions, example.jpg, star.db. *ref/head/master bin/.png equals at all. This explicitly denies write access to all other users to the bin/.png files. The negative rule overrides any implicit access. Important Asterisk modify add admins to the actual name of your Gitolite user group containing authorized users. Asterisk adjust ref/head/master to the target branch. Asterisk change bin/star.png to your specific directory and file extension patterns. You can use multiple rules for different file types and directories. Asterisk commit these changes to the Gitolite admin repository and push them to the Gitolite server. This updates the access control rules. Step 2. The pre-receive hook. The pre-receive hook is the heart of the locking mechanism. It resides on the Gitolite server and executes before any changes are committed to the repository. It checks for lock files and rejects the push if a file is already locked. 1 SSH to the Gitolite server * access the Gitolite server's file system. To navigate to the repository's hooks directory * the directory structure typically looks like this. Replace my_project with your repository's name. If the hooks directory or pre-receive file don't exist, create them. Make sure the pre-receive file is executable. 3. Create/edit the pre-receive hook * use a text editor, like 6 or Nano, to create or edit the pre-receive file. Add the following script. Explanation ****/ bin/bash, shebang line, specifies the interpreter. **lock_extension = .lock, defines the extension to be used for lock files. You can change it to something else if desired. **is_locked, this function takes a file name as input and checks if a corresponding lock file exists. If it does, it reads the lock file to get the username of the locker, prints an error message to str, important, and returns an exit code of 1, meaning the file is locked. If the lock file doesn't exist, it returns 0. *get_username, this function uses git-config get-gitolite.user to retrieve the Gitolite username of the user performing the push. Gitolite sets this configuration variable during the connection. The while red old ref name loop iterates through each ref branch being updated in the push. Git diff name only $old rev $nrev gets a list of all files modified in the push between the old and new revisions. The inner for file in $modified_files loop iterates through the modified files. If $file == bin/star.png, crucial part ** this condition checks if the file matches the pattern for your binary files. Adjust the pattern as needed to match your target file extensions and directories, example images /.jpg, data /.db. You need to change this to match the same pattern as your gitolite.conf rule. If is_locked $file, calls the is_locked function to check if the file is locked. If the file is locked, an error message is printed to str, and exit 1 rejects the push. Exit 0, if no locked files are found, the push is allowed. 4. Make the hook executable *. Step 3, lock and unlock scripts, client side. Now, create scripts that users can use on their local machines to lock and unlock binary files. These scripts will handle creating/deleting the lock files and pushing those changes to the repository. 1. Create a lock.sh script *. 2. Create an unlock.sh script *. Explanation of the scripts *. lock.sh *. takes the file name as an argument. Gets the git username from git-config get-user.name. Important * make sure users have configured their username in git, using git-config global user.name your name. Checks if the lock file already exists. If it does, it means the file is already locked. Creates the lock file, writing the username into it. Uses git add, git commit, and git push to add the lock file to the Git repository. *unlock.sh * takes the file name as an argument. * gets the Git username. * checks if the lock file exists. If it doesn't, the file is not locked. Crucially, it checks if the current user is the owner of the lock. It reads the username from the lock file and compares it to the current user's username. This prevents unauthorized unlocking. Removes the lock file. Uses git add, git commit, and git push to remove the lock file from the Git repository. 3. Make the scripts executable. 4. Place the scripts in a convenient location. Put these scripts in a directory that's in your system's $path so you can easily run them from any directory in your project. Step 4, Testing and Usage. 1. Initialize a Git repository, if you haven't already. 2. Test the locking mechanism. User A*. User B*. User B should get an error message indicating that the file is already locked. User A*. Now try to modify and push the locked file. The pre-receive hook should reject the push. User A*. User B*. Important considerations and improvements. Error handling. The scripts can be further improved with more robust error handling, such as checking if Git operations are successful and displaying appropriate messages. Timestamping. Add a timestamp to the lock file to provide more information about when the file was locked. This can be helpful for debugging and auditing. Lock expiration. Implement a mechanism to automatically expire locks after a certain period of time. This can prevent files from being permanently locked if a user forgets to unlock them. This would require a background process on the server to periodically check for expired lock files. Centralized lock management. For a more robust solution, consider using a centralized lock management system like a database or a dedicated locking service. The Git hooks would interact with this service to acquire and release locks. GUI tools. You can integrate these scripts into GUI tools or IDEs to provide a more user-friendly locking experience. Conflicts and collaboration. This locking mechanism prevents concurrent modifications, which can limit collaboration. Consider alternative approaches like Git Large File Storage, LFS, for larger binary files, though LFS doesn't provide locking either. Alternatively, explore using Git's merge capabilities more strategically by breaking down large binary files into smaller, more manageable components that can be merged. Troubleshooting. Permissions. Ensure that the pre-receive hook has execute permissions. Also, verify that the Gitolite user has the necessary permissions to create and delete files in the repository. Gitolite configuration. Double check the gitolite.conf to make sure the access control rules are correctly configured. Use Gitolite access to verify the permissions. Script paths. Make sure the paths to the scripts and lock files are correct. Git configuration. Ensure that users have configured their username and email in Git. Server logs. Check the Gitolite server logs for any errors or warnings related to the pre-receive hook. Conclusion. This tutorial provides a practical approach to locking binary files in Gitolite using Git hooks and custom scripts. It's a relatively lightweight solution that can significantly improve data integrity and prevent conflicts when working with non-mergeable files. While it requires careful configuration and scripting, it offers a good balance between simplicity and functionality. Remember to adapt the code and configuration to your specific needs and to thoroughly test the locking mechanism before deploying it in a production environment.